Welcome back to AI Decoded on ShubhCode. I'm Alex, and today we are tackling the single biggest panic sweeping through modern software engineering. If you open Twitter, LinkedIn, or Reddit right now, the narrative is completely terrifying. AI code generators are getting so fast that junior developer jobs are supposedly vanishing overnight. We keep hearing about companies freezing entry-level tech hiring while touting massive efficiency gains from Cursor and Copilot. But is this an actual structural collapse of the software career ladder, or is it just another classic tech hype cycle that people are wildly overreacting to? Joining me today is Sam, who has been building engineering teams for over 15 years and has some extremely blunt thoughts on this.
Alex, let me be brutally honest right out of the gate here. The junior developer role as we historically knew it is completely dead. This isn't just a routine market correction or temporary tech winter where hiring picks back up in 6 months. Companies are realizing that an AI agent paired with a mid-level engineer can easily outperform a team of 3 junior developers in raw output. I've personally audited engineering organizations recently where entry-level pull requests dropped by 70% because LLMs are handling the scaffolding, unit tests, and basic bug fixes. If your entire daily value proposition as an engineer was just converting Jira tickets into basic boilerplate JavaScript, you are in serious trouble.
Wait, actually, I think you're jumping to an extreme conclusion far too quickly here, Sam. Throughout the history of computer science, every single wave of automation, from high-level programming languages to low-code frameworks, was predicted to wipe out developer jobs. Instead of destroying careers, those tools abstract away tedious syntax so engineers can focus on higher-level system architecture and business logic. Why wouldn't AI simply elevate junior engineers into system designers much faster than before, rather than rendering them completely useless? Aren't we just raising the baseline of what an entry-level developer is capable of achieving on day one?
Because system architecture requires hard-earned intuition that you only get from failing while writing thousands of lines of manual code. You cannot shortcut 10,000 hours of debugging experience by simply typing natural language prompts into an interface. When a junior developer relies entirely on AI to construct microservices, they don't understand the underlying concurrency issues, memory leaks, or network latency risks hidden beneath the generated code. Sure, the code compiles instantly and passes basic unit tests today, but 6 months later your production environment explodes under real user load. Executives are trading long-term system stability for cheap, short-term velocity boosts, and it is going to backfire horribly.
That is a fair concern regarding technical debt, but let's look at what is actually happening on the ground in high-growth startups today. Founders are literally building entire minimum viable products in a weekend using tools like Cursor, Claude 3.5 Sonnet, and Vercel v0 without hiring a single dedicated front-end engineer. If small teams can iterate 10 times faster with zero traditional developer overhead, aren't traditional engineering managers forced to adapt or be left behind? You can't ignore the raw economics of getting products to market at a fraction of the cost. Is it really reasonable to expect companies to pay 6-figure salaries for code scaffolding?
Building an MVP in a weekend is easy, but maintaining an enterprise application across 5 years is an entirely different discipline. I saw a startup last month that built their entire core SaaS product using pure LLM code generation without understanding basic database indexing. Their database query times jumped from 50 milliseconds to 12 seconds the second they hit 10,000 concurrent users because the AI generated naive nested loops instead of optimized join statements. The founders spent 3 weeks frantically paying expensive consultants to rewrite their entire data access layer from scratch. That short-term saving on junior developers cost them 5 times more in emergency consulting fees and massive user churn.
Okay, but that sounds like an organizational management failure rather than a fundamental flaw in using AI tools for modern software development. If those same founders had established strong code review pipelines and continuous integration testing, those database bottlenecks would have been caught early in pull requests. Couldn't we argue that the problem isn't the AI generating the code, but rather senior leaders failing to mentor engineers on proper architectural constraints? If we train developers to treat AI output as an untrusted third-party dependency, doesn't the entire workflow suddenly become manageable?
Mentoring requires time and resources, and tech leadership currently has zero patience for proper training cycles in this competitive macro environment. Wall Street and venture capital investors are aggressively demanding immediate profitability and lean headcount across the board. When CFOs see that senior developers using AI copilots claim a 40% productivity increase, their immediate instinct isn't to hire more juniors to train, it's to cut entry-level requisitions entirely. The implicit social contract of tech apprenticeships where seniors spend hours teaching juniors in exchange for future productivity is effectively broken right now. We are actively burning down the ladder that allowed all of us to enter this industry.
If we are truly burning down the engineering pipeline, then where do senior engineers come from 7 or 10 years down the road? That seems like a massive, catastrophic ecosystem failure that no rational tech industry could possibly sustain long-term. Won't the market naturally correct itself once companies realize they have a severe shortage of experienced lead architects who actually understand fundamental computing principles? There has to be a middle ground where companies realize they must invest in junior talent to secure their own future talent pipeline.
You are assuming corporate incentives align with long-term ecosystem health, but modern tech leadership operates strictly on quarterly financial cycles. Most VPs of engineering and CTOs only stay at a company for 3 to 4 years before moving on to their next executive gig. Why would an executive spend budget training a fresh computer science graduate who won't become net positive for 2 years, when they can simply poach a senior engineer today and plug AI tools into their workflow? It's a classic tragedy of the commons where every individual company rationalizes cutting entry-level roles while hoping somebody else trains the next generation.
Wait, actually, I have to push back hard on this cynical view that junior engineers are completely doomed without hope. Isn't it equally plausible that the very definition of what makes a junior developer is simply shifting from syntax memorization to problem translation? A junior developer today who understands clear system specifications, API design, and domain logic can ship full features that used to require a team of 5 people. They aren't dead, they are being transformed into high-leverage product engineers who operate at a much higher level of abstraction from day one.
That is a comforting fantasy that tech influencers love selling on social media, but it fundamentally misunderstands how software skills are acquired. You cannot become a great system translator or product engineer without first suffering through low-level syntax errors, stack traces, and memory leaks. Abstraction without understanding is just magic, and when the magic breaks, and it always breaks, the developer who only knows how to prompt has no idea how to fix it. If you don't know how the compiler works under the hood, you are not an engineer, you are just an operator using a glorified text generator. We are diluting the exact technical rigor that makes software reliable.
Hold on, didn't assembly language programmers say the exact same thing when C was invented, and C developers said it when Java and Python took over? People argued that developers who didn't manually manage pointers and garbage collection were fake engineers who lacked fundamental discipline. Yet millions of modern developers build massive, globally distributed systems every single day without ever writing a line of assembly or manually allocating memory. Why is AI abstraction fundamentally any different from the historical abstractions that revolutionized software engineering over the last 50 years?
Because compilers and high-level languages are deterministic systems with explicit rules, while large language models are probabilistic statistical engines that hallucinate. When a C compiler translates your code, it behaves identically every single time according to strict syntax specification rules. An LLM, on the other hand, gives you subtly different, non-deterministic output every time you run the same prompt, often introducing hidden edge case bugs that look entirely plausible on first read. Relying on a non-deterministic generator as your primary development tool is categorically different from compiling code with a deterministic compiler.
That is a crucial technical distinction regarding determinism, but developers aren't using LLMs in a vacuum without testing frameworks. Modern software development relies on automated test suites, static analysis tools, and strict type checkers like TypeScript to catch non-deterministic errors instantly. If an AI generates code that passes strict automated tests, linters, and security scanners, does it really matter whether the output came from a probabilistic model or a human brain? Shouldn't we judge the engineering process by the quality of the final validated build output rather than who typed the keystrokes?
Tests only validate what human engineers explicitly thought to test, and AI code generation is notorious for missing subtle boundary conditions and obscure edge cases. If a junior developer doesn't understand the complex domain logic, they won't write comprehensive test cases that stress test edge conditions like race conditions or distributed state synchronization. They end up writing superficial unit tests that mirror the AI's naive assumptions, creating a dangerous false sense of security. The build pipeline greenlights the deployment, management celebrates fast output, and then your database corrupts silently under heavy distributed user load.
So if traditional entry-level positions are indeed evaporating under this wave of AI acceleration, what actually happens to computer science graduates graduating this year? Are you telling our listeners that young people studying computer science right now should just give up and abandon software development entirely? Or is there a specific, actionable strategy they can use to make themselves completely irreplaceable in this new paradigm?
They definitely shouldn't give up, but they must completely burn their old playbook of mass applying to entry-level front-end developer jobs with basic portfolio projects. Sending out 500 resumes with a standard React Weather app or a generic clone of Twitter is absolute career suicide in 2025. Today, a junior engineer must prove deep domain knowledge, security awareness, and an understanding of infrastructure that typical bootcamp graduates never touched. You need to position yourself not as a basic code writer, but as someone who understands system integration, data pipelines, and specialized business logic.
Let's break that down practically for someone listening who is trying to land their first software role right now. If building traditional full-stack web applications is no longer enough to get noticed by hiring managers, what specific projects should they focus on building instead? How can a beginner demonstrate high-level architectural thinking when they haven't worked in a production enterprise setting before?
Instead of generic web apps, build projects that actively handle complex real-world edge cases like asynchronous distributed task queues, local-first database sync, or custom security protocols. Show hiring managers that you understand database query performance optimization by including benchmark reports directly in your GitHub repositories. Build a project that intentionally integrates AI agents, but include explicit validation layers, latency tracking, and fallback mechanisms for when the LLM fails or times out. That proves to an engineering director that you understand production reliability, not just rapid prototyping.
That makes a lot of sense, showing that you can manage and constrain AI tools rather than just relying on them blindly. But what about the role of soft skills and business acumen for entry-level talent? In a world where technical code syntax is becoming commoditized, doesn't direct customer empathy and clear business communication become a major differentiator for young engineers?
Absolutely, and that is actually where many junior candidates have a massive potential advantage if they leverage it correctly. Engineering teams don't just need code, they need people who can talk directly to product managers, understand customer pain points, and translate business goals into technical requirements. If you can explain precisely why a specific feature architecture saves the company cloud infrastructure costs while improving user retention, you immediately stand out. The era of the isolated developer who sits in a dark corner purely writing back-end functions without business context is officially over.
I want to touch on open source contributions as well, because historically that was the gold standard for breaking into software development. Is open source still a viable pathway for junior developers to build real-world experience, or are those repositories also getting flooded with automated AI pull requests that maintainers hate?
Open source is still incredible, but only if you avoid the trap of spamming maintainers with low-quality AI-generated fixes for simple documentation typos. Maintainers are currently overwhelmed and infuriated by automated pull requests that look correct on the surface but break underlying edge cases. If you want to impress an open-source maintainer, take the time to deeply understand a complex open issue, write thorough manual test coverage, and engage thoughtfully in technical code reviews. quality contributions to established infrastructure projects carry 10 times more weight on a resume than 50 polished personal portfolio repositories.
That is such a vital distinction for open source strategy, depth of engagement over shallow quantity of pull requests. Let's talk about the enterprise side for a minute. How are senior engineering leaders actually restructuring their teams around these new workflows? Are we seeing the rise of smaller, cross-functional pod teams that operate like mini startups within big tech companies?
Yes, engineering organizations are consolidating rapidly into hyper-focused, autonomous micro-teams consisting of 2 or 3 senior engineers backed by powerful AI tooling. These lean pods are replacing traditional 12-person engineering squads that previously required multiple junior engineers for maintenance and testing. This shift allows tech companies to dramatically reduce communication overhead while delivering features at double the speed. But again, it creates an extreme demand for developers who understand end-to-end system ownership rather than specialized, single-stack task execution.
If team sizes are shrinking while individual scope is exploding, what does this mean for computer science education in universities and coding bootcamps? It feels like higher education curricula are completely disconnected from the actual day-to-day realities of modern software engineering teams.
Traditional computer science education is currently operating about 5 years behind industry reality, focusing heavily on rote algorithm memorization and theoretical textbook syntax. Bootcamps are in even worse shape because many are still selling 6-month web development programs designed for the 2018 tech boom economy. Universities urgently need to pivot their curricula toward cloud architecture, AI safety evaluation, systems design, and cybersecurity fundamentals. If educational institutions don't adapt immediately, their graduates will remain entirely unhireable in a market that demands instant, high-leverage production value.
So for senior developers and tech leads who are listening to this episode right now, what is their responsibility in this changing landscape? Should senior engineers be actively advocating to retain junior roles within their companies, or should they strictly focus on optimizing their own AI-augmented output?
Senior engineers have an ethical and strategic responsibility to advocate for sustainable apprenticeship models within their organizations. If senior devs don't actively design structured mentorship pipelines that utilize AI as a learning accelerator for juniors, our entire industry will face an absolute leadership crisis in 10 years. They should create paired programming sessions where juniors learn how to audit, test, and refactor AI-generated code rather than simply letting automation eliminate those headcount allocations. Protecting entry-level talent is essential for the long-term health of software development as a whole.
That is a powerful call to action for engineering leads who care about preserving the future talent pipeline of our industry. Let's bring this all together. If you had to condense your advice for ambitious developers trying to thrive in this AI transition into one core philosophy, what would it be?
Stop thinking of yourself as a code writer and start viewing yourself as a systems orchestrator and business problem solver. AI tools will write syntax faster and cheaper than you ever can, but they cannot care about product reliability, user intuition, or business outcome alignment. Master system design, embrace automated validation, and focus relentlessly on domain expertise that can't be scraped into a training set. The developers who master the bridge between high-level human problem framing and AI execution are going to build the future.
That is an insanely empowering mindset shift when you really pause and process what it implies for the future of software engineering. It turns AI from an existential threat into the ultimate force multiplier for developers who are willing to level up their core systems thinking.
Exactly. The engineers who adapt today aren't losing their jobs. They are gaining superhero capabilities that allow them to build software that previously required entire venture-backed startups to execute. The future belongs to those who embrace technical rigor while delegating repetitive syntax to automation.
That brings us to the end of another incredibly sharp discussion here on AI Decoded. A massive thank you to Sam for coming on and delivering some real, unfiltered engineering truth today, and thank you to everyone watching and listening on the ShubhCode channel. If this episode made you rethink your developer career strategy, make sure to hit that subscribe button, drop your thoughts in the comments below, and share this with your fellow developers.
Thanks for having me on, Alex. Keep building, keep learning underlying computer science fundamentals, and don't let the AI noise distract you from becoming a truly great problem solver. See you all in the next episode.